These notes are for AP Calculus AB. This is objective 8.7, where we'll be talking about the derivative of a to the power u. So we already learned the derivative of e to the power u. This is more general. So a, where a is any positive real number, and so its derivative is given by this formula. So d dx of a to the u is just like with e to the u. We get a to the u itself times the natural log of a, then your chain rule du dx. So this is formula number 9 out of the 10 that we're doing in this unit. And I'm going to start by showing you how you can actually use this formula on the derivative of e. So for example 1, okay, if we apply this formula to our derivative for e to the u, since e is a positive real number, our formula should work here. So we start with the derivative of e to the u. So e, a positive real number, to the power u is e to the u times the natural log of the base a, which is e in this case, the natural log of e, and then followed by du dx. Since natural log and e are inverse operations, they simply undo one another, and they leave behind the exponent of e, which is 1. So this does turn into e to the u du dx. And that is our formula for the derivative of e. All right, so here we have y is equal to 2 to the power 4 plus x squared. We want to find y prime, our derivative. So we start always with a copy of what we began with. So 2 to the power 4 plus x squared. We then want to multiply that with the natural log of the base, so the natural log of 2. Followed by our chain rule, derivative of the exponent, u. So derivative of 4 plus x squared would give us 0 plus 2x. All right, so these are all the pieces that make up my answer. And then sometimes there's just ways that we can rewrite our answer. So let's pull 2 into the front of our natural log. So I'm going to move this 2 here as the coefficient of my natural log. And then we'll just put x in a nice spot. Maybe we'll leave it at the back. But natural log 2 is a number. 2 times the natural log of 2 is a number. This is really my coefficient, so I might just pull it all to the front. All right, so for now, we'll leave it where it is. So I bring this 2 here in front of the natural log of 2. I'll leave the x here at the back. What I want to do is use my log property. So I can rewrite this 2 as the exponent of the 2 inside of my natural log. So it becomes the natural log of 4. So just showing you that there's some ways that you can rewrite the values when you have numbers in front of your logs with your power rule. That is it. That makes up all of the pieces. You can rewrite these things in any different order that you might prefer, but we can always just leave it this way. All right, so taking the derivative of 4 to the power square root x. So we'll start again with a copy of what we started with, times the natural log of our base. And then we want to take the derivative of our exponent. So the derivative of any square root function is 1 over 2 root x. Now, you would want to take the derivative of what's inside of that, but that's just going to give us 1. So that finishes the derivative for the exponent. So like last time I had this 2, I brought in front of my natural log 2. This time I have a 1/2 that I can bring in front of my natural log 4. So we're going to take the 1/2 here, bring it in front of the natural log of 4. And we'll write this as 4 root x times 1/2 natural log 4. And we still have our 1 over root x. So if I put this 1/2 exponent back, or the coefficient back as the exponent, it becomes 4 to the 1/2 power, or the square root of 4, which turns into 2. So I now have 4 root x times the natural log of 2, and then I'm going to go ahead and just write it all divided by square root x. Okay. Problem number 4. So the derivative of 3 to the power negative 2x. We're going to start with, we get a copy of what we started with, 3 to the power negative 2x, multiplied by the natural log of our base, followed by the derivative of our exponent, negative 2. So this time I've got a negative 2 that I can move as the coefficient. All right, so negative 2, we're going to bring it in front of our natural log. If we rewrite this as our exponent, we are going to end up with 3 to the power negative 2. We're going to clean up those negative exponents. So that 3 to the power negative 2 will make the natural log of 1/9. I want to avoid having too many fractions in the problem. So I think what I'll do is I'll separate the negative and the 2. So this will just make my work a little bit faster in the long run. I'm going to leave the negative down here, just out front, there's a negative, and then just move the 2 back as my exponent. Okay, so the negative, let's just pull it out to the front. 3 to the power negative 2x times the natural log of 3 squared. So 3 squared becomes 9. So to finish, all I want to do is move the 3 here down underneath my natural log so that I won't have this negative exponent anymore. So I'll keep the natural log of 9 here. We'll move 3 to the power 2x to the denominator, and then we still want to have this negative coefficient. So that will be my answer. All right, number 5. So this time my function is made up of a product of 2 other functions, x squared and 5 to the power natural log x. To find the derivative then, we'll need to use our product rule. So we'll start here with the first term times the derivative of our second. So 5 to the power u is 5 to the power natural log x times the natural log of our base times the derivative of our exponent. So the derivative of natural log x is 1 over x. So that is just first times the derivative of the second plus the second term times the derivative of the first term. That'll give us 2x. So there's a little bit of simplifying I can do here with x squared over x. And then you'll notice that both terms have some things in common. A natural log of 5, the 5 to the power natural log x. That's what they have in common. This term here, and then they also both have an x term. So I'm going to factor out those values. So an x and 5 to the power natural log x. So taking these two terms out leaves us with a natural log of 5. And over here, we took out these two terms and we're left with 2. So that is going to be our answer there. All right, so that's really all the examples I have to go over with that formula for a to the u. So I hope after 5 problems that's felt like a good amount of practice to get this extra piece stuck in your memory. It's a little bit different from the e to the u formula because it has that natural log of the base in it. And with e to the u, that value just simplified out. So there's a little bit more for 8.7, and we're going to look at what happens if you see a log that is not a natural log. So last year, you most likely learned the change of base theorem. You learn this in your log unit. So it was, what happens if I have a log that I don't want to use? How do I change it so I can make it into a log that I do want to use? And for us, it's useful because we only want to work with natural logs. So you start with some given log base a of x. Well, we don't want log base a. We only want natural log. We want a log with a base of e. So it's very simple. All you do is take the natural log of x and divide it by the natural log of a. So that is our change of base theorem. And we're going to use that so we can then take our derivative because we have a formula for derivatives of natural log x. So just a couple examples here. So you'll notice it says f is log base 2 of root x cubed minus 5, and we'd like to find the derivative here, f prime. So before we get started, we want to change the base and we want to change it into a natural log. So this is going to become the natural log of x, which is our stuff inside, divided by the natural log of a, which is the old base, 2. So f of x becomes the natural log of root x cubed minus 5 divided by the natural log of 2. Now, the natural log of 2 is just a coefficient because it's just a number. So we're going to pull that out to the front, 1 over natural log 2. We're left with times the natural log of, let's write this as x cubed minus 5 to the power 1/2. And with my log properties, I'll bring that 1/2 power in front with my 1 over natural log 2. So 1/2, 1 over natural log 2, and I'm left with the natural log of x cubed minus 5. Well, to take the derivative, you'll keep your coefficient here. Remember that 2 and natural log 2 are just numbers. And then all you need to do is take the derivative of this natural log by using your formula. So 1 over the stuff inside times the derivative of what's inside. So I do want to put these together. So remember that the coefficient of your natural log can become the exponent of the number inside. So this 2 becomes the exponent of this 2, and this becomes 1 over the natural log of 4. So when I take my derivative, I want to make sure that that's part of it. So now I have 1 over the natural log of 4. And I go ahead and start in on my derivative here. So derivative of any natural log is 1 over the stuff inside times the derivative of what's inside, 3x squared. So just by doing a little bit of prep work, we have a very easy derivative to take. Nothing that will simplify here. So we're just going to push the two things together. And that will be our answer. So let's try it one more time. All right, so before we get started, we'll use that change of base theorem. We don't want a log base 5, we want a natural log. So we're going to take the natural log of x, which is everything inside. This is x, over the natural log of a, which is the old base. So this will become the natural log of x squared minus 1 over 3x plus 2 divided by the natural log of 5. So this natural log of 5, just like last time, it's a number, so we're just going to pull it out front. 1 over natural log 5. The rest of it here that's left, we'll start using our log properties. So our quotient property lets us do the natural log of the numerator minus the natural log of the denominator. So you're creating two terms out of one, and because you have a coefficient here, you want to make sure you use some brackets or parentheses for everything that follows. So the natural log of x squared minus 1 minus the natural log of 3x plus 2. So no other log properties that we can use to simplify before we take our derivative. So we'll go ahead and start in on the derivative, g prime of x. So I have my coefficient, and we'll do our derivative inside here. So 1 over x squared minus 1 times the derivative of x squared minus 1, which is 2x, minus 1 over 3x plus 2 times the derivative of what's inside, which is 3. Not a whole lot to be gained from trying to get a common denominator and simplifying, although you could, so we'll just leave this as our final answer for now. All right, so those are all the examples I have for you today on 8.7. So we did the derivative of a to the u, which is a new formula. So we need to make sure we know that one as well as the others. And then I've now shown you how to take a derivative of a log if it's not already a natural log.